So welcome to our workshop.
So my name is Amanda.
And my name is Kristen.
Kristen and I are both SUNY Plattsburgh students, and we're in the education program. So we're studying to be teachers, and we're going to teach you guys about Katherine Johnson and how she was so important to the Apollo 13 mission.
All right, so we want you all to try and solve this equation and give it your best effort. So it says a particle is projected from the ground with an initial speed of v at angle theta with horizontal. The average velocity of the particle between its point of projection and height point of trajectory is, and look at your answer choices A, B, C, and D. So let's all take a second and try and solve this problem.
I don't know, Kristen, this is pretty hard.
I agree. We're both college students and we can't figure it out too. So I want you all to think about how hard this question was for you at your age. And something that you might not know is that Katherine Johnson could solve this problem at your age. So third through fifth grade, 8, 9 years old, she could solve this problem. And it's so tricky, even for us at 21 years old.
Okay, so who was Katherine Johnson? So she was born August 26, 1918. She just recently passed away last February at 101 years old. So she lived a really long time. She went to West Virginia State University, and she was only 15 years old when she went there. And then she spent 1 year at West Virginia University to become a mathematician. And eventually she was able to get a job at NASA, and she worked there for 30 years. And during that time is when she was working on the Apollo 13 mission. And she had two very important colleagues, Dorothy Vaughan and Mary Jackson. And these three women are considered the hidden figures of the Apollo 13 mission.
So we are going to watch the opening scene from the movie Hidden Figures. So you may have seen it, or maybe a family member has seen it, and pay attention to where you see Katherine Johnson in the clip, and you're going to learn all about her childhood, and just ignore the subtitles on the bottom. They are in Spanish, so if that helps you, great, but just pay attention to what you're hearing.
14, 15, 16, prime, 18, prime, 20, 21, 22.
West Virginia Collegiate Institute is the best school for Negroes in the state.
It's the only school past the 8th grade anywhere near here.
Isosceles, scalene, equilateral, rhombus, trapezoid,
Catherine's in the 6th grade.
They want to take her early.
tetrahedron, dodecahedron.
They're offering a full scholarship. All you have to do is get there.
Miss Coleman, why don't you solve the equation on the board?
We took up a collection amongst the teachers and such. It's not a lot, but it's enough to help get you settled in.
That's more than kind, Miss Sumner.
If the product of two terms is 0, then common sense says at least one of the two terms has to be 0 to start with. So if you move all the terms over to one side, you can put the quadratics into a form that can be factored, allowing that side of the equation to equal 0. Once you've done that, it's pretty straightforward from there.
In all my years of teaching, I have never seen a mind like the one your daughter has.
Hurry on now, love.
You have to go.
Let Mama tuck me in.
You have to see what she becomes.
Okay.
All right, so now that we watched the beginning Hidden Figures, we're going to read a book that explains a little bit more about Katherine's life. So counting on Katherine, how Katherine Johnson saved Apollo 13. Katherine loved to count. She counted the steps to the road, the steps to the church, the number of dishes and spoons she washed in the bright white sink.
The only things she didn't count were the stars in the sky. Only a fool, she thought, would try that. Even so, the stars sparked her imagination. What was out there? Katherine yearned to know as much as she could about numbers, about the universe, about everything.
Katherine's boundless curiosity turned her into a star student. She was so bright, she skipped 3 whole grades. She catapulted right past her brother. He wasn't too happy about that.
By the time she turned 10, Katherine was ready for high school. But back then, America was legally segregated by race. Her town's high school didn't admit Black students of any age. Katherine burned with fury. She wanted more than anything to keep learning. There was still so much to know.
Count on me, Katherine's father told her. By working night and day, he earned enough money to move the family to a town with a Black high school.
Katherine loved high school. She was good at every subject, but math was still her favorite. She dreamed of becoming a research mathematician, making discoveries about the number patterns that are the foundations of our universe. In those days, though, there were no jobs as research mathematicians for women. Professions most available to them were teaching and nursing. So Katherine became an elementary school teacher. She liked her job and she loved her students, but she never stopped dreaming about exploring numbers.
In the 1950s, the US government's National Advisory Committee on Astronautics, or NACA, hired thousands of new employees, even starting hiring Black women as mathematicians. Katherine heard about the mathematician jobs. Her heart raced with excitement. Perhaps her dream could come true after all. But when she applied for one of the positions, she was told they were already filled. Katherine had to wait a whole year until new spots opened up. Her patience paid off. She got the job.
A few years later, the Soviet Union sent a rocket ship into space, launching a space race with the United States. NACA was rolled into a new space agency, the National Aeronautics and Space Administration, NASA. Katherine now found herself at the heart of America's space program. She worked as a computer. Electric computers were not widely used yet, calculating long series of numbers. All the computers were women. They were given the tasks that men thought were boring and unimportant. That didn't bother Katherine. She knew that without her contributions, a spaceship couldn't reach its destination, nor safely return to Earth.
Here's why. Sending a rocket ship into space is like throwing a ball in the air. At first, the force of throwing sends a ball up, up, up. But when its energy runs out, the ball's path curves towards the ground. Where it lands depends on the angle it's thrown and how high and fast it flew. Because math is kind of language, Katherine could ask those questions. How would the rocket ship go and how fast would it travel using numbers? And numbers would provide the all-important answer. Where would it land? To find out, Katherine plotted the numbers she calculated on the graph. When she joined the points together, they formed a curved line. At the end of the line was Earth, at the same time the rocket ship launched. At the other end, where Earth would be when the ship landed.
Katherine's reputation for accuracy and strong leadership skills, she was known for asking plenty of questions, got her promoted to Project Mercury, a new program designed to send the first American astronauts into space. Mercury's missions were going to be dangerous, so dangerous that even the project's star astronaut, John Glenn, refused to fly unless Katherine okayed the numbers. "You can count on me," she said. Glenn's spacecraft, Friendship 7, orbited Earth 3 times and returned home safely. Glenn became a national hero.
Katherine was promoted again. Now she was asked to calculate the flight paths for Project Apollo, the first flights to the moon. Count on me, she said. On July 20th, 1969, the Apollo 11 astronauts walked on the moon. Their feat was celebrated around the world. More triumphs followed. Apollo 12 rocketed the moon in November 1969.
Apollo 13 launched on April 11th, 1970. But on the third day of Apollo 13's flight, the worst thing happened: an explosion in space. Could the crippled spaceship make it to the moon? And if it didn't, would it be able to get back home to Earth? The 3 astronauts on board were in grave peril. Commander Jim Lovell told Mission Control, "Houston, we've had a problem."
Back on Earth, Katherine Johnson got the phone call. Her flight path calculations would have to be done all over again, and perfectly. It would be the toughest challenge of her life. Katherine told Mission Control, "You can count on me." She rolled up her sleeves, took a deep breath, and began doing the math. She worked hard and fast. A few hours later, Katherine's calculations were finished. The flight path to return home would take the ship around the far side of the moon. From there, the moon's gravity would act like a slingshot to sling the ship back towards Earth. To get home, the crew of Apollo 13 would have to follow Katherine's course exactly by burning off fuel at precise intervals. If the astronauts made a mistake, their ship would drift through space forever.
Katherine waited anxiously to hear the astronauts' report. Finally, it crackled over the loudspeakers. "We've got it! Apollo 13 was back on track."
Katherine Johnson had done it. She brought Apollo 13 home. She was no longer the kid who dreamed of what laid beyond the stars. She was now a star herself.
The end.
Okay, so now that we've read a little bit more about Katherine, I want you guys to take a second to think about, how did Katherine show grit and curiosity? But Kristen, what is grit?
So grit is when you work really, really hard on something and you never give up. So you're very determined and you keep going after your dreams. Do you know what curiosity means?
So curiosity is when somebody is really passionate and they have interest in finding out new things. So like Katherine, she went to college at a young age and she graduated early because she had so much interest in learning. And just like you saw in the book, when she was working on Project Mercury, she had so many questions because she was so interested in what she was doing.
And Katherine showed her grit because she never gave up and got the job of her dreams working at NASA, even though she had to wait a year. So she was very persistent and kept going after her goals, even though she had to wait. She was eventually hired.
Also, when she was redoing her calculations for Apollo 13, she had to work really, really hard and fast because those astronauts were relying on her to get them home safely. Because if they didn't do exactly what she said, they'd be stuck in space forever.
So we've talked a lot about Apollo 13. So we want to give you a chance to think about what Apollo 13 would look like if you had the chance to design it. So on the left in the circle, that's a picture of actual Apollo 13. So if you have a piece of paper near you and maybe a pencil or a crayon, make a very, very quick sketch of what you would want your Apollo 13 to look like. And if you don't have paper, that's okay. Just take a second and think about it in your head.
Okay.
So we're gonna give you guys a nice view of what we're doing here. Hopefully you've had a second to think about what you would do or what you would want to sketch. And we are going to show you what we came up with for our Apollo 13. So Amanda's gonna show you different materials that we thought of to use to design our own spacecraft. So first thing we have, Amanda is using a plastic bag, some ribbon and string, and a piece of tin foil with some tape to hold it together, and then a bucket on the ground with some water in it.
So when Apollo 13 landed, they actually landed in the water. So this is going to represent the ocean. It's very, very small, but Katherine had to make sure that they landed exactly on the right spot to be safe. So we're going to see different ways of how Katherine could have gotten them to land. So right now, if I'm using the plastic bag as a parachute, let's see if I can get this into the water.
That wasn't really close at all. So let's see if we can change some things up. Let's do it one more time. Let's see. Not even close to the water there. So let's try and change the type of parachute that we're using. So if you'd like later after school today, or if you're at home right now, you can get some materials and test out your sketches and experiment and see all the things that Katherine had to take into consideration with her calculations. So Amanda just changed to use a coffee filter as our parachute. So instead of the plastic bag where lots of air can get underneath it, we're using a smaller parachute that's a coffee filter. So let's see. All right, that was pretty close to getting in the water. Let's try it one more time. Oh, it's just missing it. So it's maybe by this much, it's a little bit behind the water. So let's try and change something else. So we've tried changing our parachute, and we've noticed that the direction of Apollo 13 is a factor. Sometimes it spins. So maybe let's add some mass. Amanda is adding another piece of tinfoil to our the bottom of our Apollo 13. So the mass is going to make it a little bit heavier. And let's see if more tinfoil helps Apollo 13 reach the water. All right, it's close. Let's try one more time.
It's going really fast now.
Oh.
It's hard to control it.
Okay. Made it in the water. So it took a few trials, but you can see that sometimes it would spin. The direction, it kept moving, and it was a lot faster. Amanda said it was a speed, so velocity was something we have to take into consideration too. So we're going to try one more thing. We're going to remove the mass and see if we change the height that we throw, that we release our Apollo 13 from makes a difference. So Amanda's going to stand on a chair. And right now she's just getting our next trial of our experiment set up, which you can do multiple trials at home, get different household materials like we have. And let's see if our height, so how high we're releasing our Apollo 13 from, helps us get it into the water. Okay, so it's veering a little bit off to the side of the water. We're going to try it one more time. Okay, look at that, went right in the water perfectly. So what do you think, Amanda? I think this was our best trial yet.
I think so too. It took a lot of different tries to fix it, but you saw eventually it was able to get into the water. But we had so many tries to do it. Katherine had one chance to get that right, to make sure that John Glenn and everybody else on that spaceship was safe.
So she had to take into consideration the mass, the height, the velocity, if it was spinning, different angles. There were so many factors that she needed to consider. And if one thing was wrong, then the whole mission would not be successful. So hopefully you got some ideas for experiments that you can do when you're home later, and use some materials and practice stepping into Katherine Johnson's shoes and seeing what she had to go through and how much pressure was on her shoulders.
Okay, so we've learned a lot about Katherine and the Apollo 13, but I want you, if you're in class, turn and talk to somebody, or if you're at home, you can think to yourself, what do you think Katherine accomplished after the Apollo 13? Just take a minute and think about that.
Okay, so some accomplishments after Apollo 13. This was just the beginning of Katherine's career. She was so successful, and she actually helped develop the space shuttle program. So this program existed for about 30 years, and it's no longer occurring, but it was around for a very long time. And they worked on building spacecraft to send into outer space and doing research up there. And their biggest creation was the International Space Station, which is where we saw the astronauts in the downlink before. And Amanda and I watched it. We thought it was spectacular. We were so amazed at what they were doing up there. And that was one of the key inventions of the space shuttle program was the space station you saw our 2 astronauts on.
All right, so another thing she did, she worked on Earth's resource satellite. So when we get satellite pictures, that's how we're discovering about space. So all the pictures that we get from space, Katherine Johnson played a part in that. And we're learning about things like Earth's rotation, Earth's assets, why we have seasons, weather, all that kind of stuff, and learning about our solar system. Katherine developed part of the ways that we can take these pictures.
And she also helped plan for a mission to Mars. So we know that Mars is one of the planets in our solar system. So it's one of the planets that we think could be very similar to Earth, and we're searching for life on Mars. So Katherine was key in helping plan for a mission that sent astronauts up there to see if there's life on Mars.
A really important thing, in 2015, she received the Presidential Medal of Freedom and the Congressional Gold Medal. So in the previous picture, you actually saw President Barack Obama giving Katherine her award. And this is something that recognizes US citizens who do really good things for America. So like Katherine doing things like Apollo 13 and other things gave her this very prestigious honor.
And NASA also dedicated a new computational research facility to Katherine. So computational is like we saw in the book when Katherine was referred to as a computer, not like a computer you may be watching us on or something you use for school, but a computer. So meaning you compute things like math and you do different calculations. So this facility is devoted to doing calculations needed to put spacecrafts into space. And the facility, so a building, was named after Katherine in honor of the work that she had done for NASA.
So although Katherine has passed away, just this year she was inducted into the Women's Hall of Fame, which just recognizes famous women throughout history and important things that they've done in their lifetime.
So now we have a collage of many pictures from Katherine's life. So we're just going to highlight a few that we really want you to notice.
Okay, so in the bottom here where she has the medal, and then in the top corner, those are both from when she received that presidential honor. In the top corner, those are her daughters. And then a really interesting thing in the bottom corner, that is her computational research facility. So she was able to see it before she passed away. And then in the bottom, that's from Hidden Figures when they won the Oscar. And the woman who's right behind her in all black, she's the one who played Katherine in the movie. So if you guys want to watch it, you should. It's a really good movie. You're going to learn a lot about Katherine. But they did invite her to the Oscars when they won. So that's really cool that she got to have that honor.
All right, so we are going to open it up. If anyone has any questions that they would like to ask us about Katherine, we hope that you learned how to be gritty and how to show your curiosity, and you can always go after your dreams, especially women. I know there are not as many women in STEM as men, so keep going after your dreams, use your grit like Katherine, and go after what you want. And maybe you can be the next astronaut aboard the International Space Station, just like Megan, who we saw in the Downlink. So please write any questions that you have for Amanda and I in the chat. If you're in a classroom, your teacher can type them in for you, and you can talk about it with your classmates, and we can answer them to the best of our ability.
I just want to pop in real quick and say thank you. That was amazing. I know I learned something, so I'm sure everyone else did as well. And I'll give a couple minutes just see if there's any questions or anything. And then we're good. Thank you. That was really good.